Section 1, Cosmic Dance Floor, where asteroids waltz. Space is big, really big, and it's filled with amazing things. Among them are asteroids, remnants from the early solar system. Imagine a cosmic dance floor filled with these rocky bodies, twirling around the sun. They come in all sizes, from tiny pebbles to massive behemoths. Some are as small as a car, while others dwarf Mount Everest. Each one holds clues to the universe's history. Asteroids are like time capsules, preserving secrets from billions of years ago. They're made up of the same stuff that formed our planets. By studying them, we can learn about the ingredients that created Earth and everything on it. Think of them as cosmic fossils, offering glimpses into our solar system's turbulent past. But asteroids aren't just relics of the past. They're active players in the solar system's ongoing story. Their orbits can change, sometimes bringing them close to Earth. While most are harmless, some pose a potential threat. That's why scientists are constantly watching the skies, tracking their movements. Section 2, Space Rubble. It's all about size. We categorize asteroids by size, like sorting cosmic cookies. The smallest, called meteoroids, are just specks of dust. Next come the meteoroids, ranging in size from a grain of sand to a meter across. These often burn up in our atmosphere, creating fiery streaks we call shooting stars. Then we have the asteroids, the real heavy hitters. They can be tens to hundreds of kilometers wide. The largest, OSIRIS, is so big it's classified as a dwarf planet. But even smaller asteroids can pack a punch. Remember the dinosaurs? An asteroid impact likely played a role in their extinction. But size isn't everything. Asteroids also differ in composition. Some are mostly metal, remnants of planetary cores. Others are rocky, made up of silicates and carbon. These differences tell us about the conditions in which they formed. Section 3, Vesta, a giant with a bite taken out. Let's meet a celebrity asteroid, Vesta. This giant is the second largest in the asteroid belt, with a diameter of about 530 kilometers. Vesta is unique because it has a giant crater near its south pole. This crater is so big that it covers a significant portion of Vesta's surface. Scientists believe this impact gouged out a huge chunk of Vesta billions of years ago. The debris from this collision scattered throughout the solar system. Some of it even landed on Earth as meteorites. By studying these meteorites, we've learned a lot about Vesta's composition and history. Vesta is like a giant puzzle piece, helping us understand the early solar system. Its unique features tell a story of violent collisions and planetary formation. It's a reminder that even in the vastness of space, no object is truly isolated. Now let's talk about Bennu. This asteroid is much smaller than Vesta, only about 500 meters in diameter. But Bennu is special because it's shedding light on the origins of life itself. In 2020, NASA's OSIRIS-REx spacecraft visited Bennu and collected samples from its surface. These samples are currently on their way back to Earth, and scientists are eagerly awaiting their arrival. Bennu is a carbon-rich asteroid, meaning it contains organic molecules. These molecules are the building blocks of life as we know it. By studying the samples from Bennu, scientists hope to learn more about how these molecules formed and evolved in the early solar system. This could provide valuable insights into the origins of life on Earth and the possibility of life elsewhere in the universe. While most asteroids pose no threat, some have Earth in their crosshairs. That's why astronomers are constantly on the lookout, scanning the skies for potential hazards. They use powerful telescopes to detect and track these space rocks, plotting their orbits with incredible precision. If an asteroid is found to be on a collision course with Earth, there are several strategies to avert disaster. We could nudge it off course with a spacecraft impact, or even use a nuclear weapon as a last resort. It's like a cosmic game of billiards, with the fate of our planet at stake. Asteroid hunting isn't just about preventing catastrophe, it's also about understanding our place in the cosmos. By studying these celestial wanderers, we gain a deeper appreciation for the delicate balance of our solar system and the importance of protecting our pale blue dot. From tiny pebbles to massive behemoths, asteroids are more than just space rocks. They're cosmic storytellers, carrying within them the history of our solar system. By studying their size, composition, and orbits, we gain invaluable insights into the processes that shaped our cosmic neighborhood. Each asteroid is a piece of the puzzle, helping us understand the origins of our planet and the potential for life beyond Earth. So the next time you look up at the night sky, remember those tiny points of light. They're not just distant objects, they're echoes of the past, whispering secrets about our place in the universe.